Hi friends, so today we are going to do one easy interview question. So here what we are given is one array and one to move integer. So we just have to move all the elements which is present in to move to the end. So we are given two inputs and we just need to return an array wherein all the elements given in this variable is moved in the end. So for example, in this case 2 move is 2, so we have moved all the 2's to the end of the end of the array, and the order of this one doesn't matter. So in the end only the two moved elements should be placed in the right. All the two moved elements should be placed in the right. So that's it, that's the question. So how do we do this? So we can do this using two ways. First one, I'll teach you how I did it, but if you can after that I'll teach the more elegant ways. So that is the best approach. So let me tell you how I solved it. So here, so first step is to create, so one second. Yeah, so the first step is to create two pointers. So step 1, create two pointers, so one at the start and one at the end. And step 2 is iterate until this left pointer is lesser than the right pointer. So next so what are the cases which can occur? So for example, let's take the first case as one second. So let's take this first case as 2, 4. So 2 LP is pointing to 2 and RP is pointing to 4. So in that case what we have to do is, so 2 should come over here and 4 should go over there. So this is the case when if LP is equal to 2 is equal to 2 and then RP is not equal to 2. So in that case what we have to do is we need to exchange these both elements. So we exchange, and then so after they are exchanged, so after they are exchanged we get something like 4 and 2, 3, 2, 2, 2 and 1. So 4 comes here and 2 goes there. So leave this 2 for now. So this is the first example. So after exchanging, the pointers are still pointing over here. So what we have to do, we have to increment left pointer to this one, and the right pointer we need to decrement it by 1. So RP minus minus and LP plus plus. So this is the first case. So let's move to the second case. So next is one else if. So both LP and if both LP and RP is pointing to 2, if LP is equal to 2 and then RP is also equal to 2, so in that case we have to do so this is the case when both LP is equal to 2 and RP is equal to 2. We have to move. See, this is already 2, we don't need to touch this thing, so we need to just check for the next element. So we just need to move this one over here. So what is this? So RP minus minus. So next case, else if LP is not equal, else if left pointer is not equal to 2 and then right pointer is equal to 2. So left pointer is not equal to 2, so take this one, and the right pointer is equal to 2. So in this case we don't need to, since the right pointer is already correct, it is already in 2's position, we don't need to make any changes, right? So now currently our elements are this one. So now again it will check. So this case will come. So again 2 and 4 will get exchanged. So in the end we will have 4 will come here. 4 will come here. Next 1, 2, 2, 2, 3, then 2, 2, 2. So yeah, so this is the, so first we created 2 pointers, then the first iteration happened. So after the first iteration first it was pointing to 2, 2. So first this left pointer was pointing over here. So first this left pointer was pointing over here. So LP is equal to 2 and RP is also equal to 2. So we made it point over here. So next again it will go back up. LP is lesser than RP if LP is 2 and RP is not equal to 2. So in this case RP is not equal to 2. So what we did, we need to exchange both these elements. So 4 will come in the end and 2 will come over here. So next we need to do RP minus minus since and LP plus plus, since we are done with these both positions. So what we do is, initially it is in these points, so we do LP plus plus and RP minus minus. So it is pointing presently over here. So after this again we go back up. So next LP is 2 and so next what is the condition? LP is not equal to 2 and RP is also not equal to 2. So I think this is the last condition. If LP is not equal to 2 and then RP is not equal to 2. Oh, sorry. So in this case we need to do LP plus plus. So now we are doing, for this case, LP is not equal to 2 and RP is not equal to 2. So what we have to do is we need to do LP plus plus. Why LP plus plus? Because we are here, right? So we need to increment this one to check if there are any 2's between this element and this element. If there are 2's, they have to be exchanged. So now if LP is not equal to 2 and RP is not equal to 2 is true, so what we do is we drag it here. So next again it goes back up. So LP is lesser than RP. If LP is 2 and RP is not equal to 2, so we exchange. So we exchange those two elements. So it will be 4 comma 1 comma 3 comma 2 comma 2 comma 2 2 comma 2. So after exchanging, we increment left pointer and decrement right pointer. So initially it will now point here. So initially it was pointing to this one, so now it will point over here. So next again it will come back up. LP is lesser than RP. So LP is equal to 2 and RP is equal to 2. It will again do RP minus. So right pointer will come over here. So and then again it will do RP minus, and then right pointer will come over here, and yeah, then it will break out and it will give the output. So that's it. So next step 3 is to return array. So this is an okay solution. I mean, time complexity is O of n, and space complexity is also O of n, since we are returning an n-dimensional an array having n elements. So after this, so let's look at I have already implemented this solution. Is very easy, so I've already implemented this solution, but let's implement a better solution. So what we have here is the question is 2 comma 1 comma 2 comma 2 comma 2 comma 3 comma 4 comma 2. So this is our question. So initially we need to do the same thing. So create LP is equal to 0 and int RP is equal to place it at the end, array dot size -1. So now what we need to do is, if the pointer is over here and over here, so let's make it 2 comma 2 comma 2 comma 2. So okay, so for the first step, what we can do is we can keep on iterating until we find one number which is not equal to the to do, which is not equal to 2. So what we do is we need to keep on iterating while LP is lesser than RP. So this is the basic condition, LP is lesser than RP. So we keep on iterating until we find an element which is not the match. So while array dot get of right pointer is, if it is equal to 2, okay, you keep on iterating towards the right side. So rp minus minus. So when we do this, first it will check here, okay, LP is lesser than RP, is condition satisfied. Then it will get RP is equal to 2, yes it is, so it will come here. Next again it will come here, LP is lesser than RP, RP is equal to 2, next again it will decrement, next again it will decrement, next again it will decrement, next again it will come over here, LP is lesser than RP, then RP is equal to 2, yes, so again it will decrement, it will now point to 4. So now again it will check LP is lesser than RP, and then array dot get RP is equal to 2, no, because array is now, it is now pointing to a 4, so RP will now be pointing to 4. So after this one, so now it is pointing to 4, right? So if so this is 4, it has to be exchanged with 2. So if left pointer dot get LP, so if this, so now it is standing at 4, right pointer, so now left pointer is standing at 2. So if array dot get of left pointer is equal to 2, so if array dot left pointer is equal to 2 and this one is pointing at 4, we need to exchange. So swap. So how do we swap? So first get the int left num is equal to left number is equal to array dot get of LP, next int right number is equal to array dot get of RP. So once we get, we just need to exchange. So array dot set of left pointer with whatever is there in right num, array-gt num. So next array dot set of right pointer must point to whatever there is left num, okay, so then this exchange is complete. So once we exchange this one, what we'll get, we'll have a 2 over here and we'll have a 4 over here. So the left pointer will be still be pointing to the first element, so over there the work is done. So after exchanging we need to do LP plus plus. Okay, so after doing this, again it will go back up. LP is lesser than RP, so left pointer will be over here, and so LP is lesser than RP, and array dot get right pointer if it is 2, so it was 2, right? So again it will keep on coming till it reaches 3. So as soon as it reaches 3, so 3 and 1 we need to deal with 3 and 1. So if array dot get let pointer, so this one is not satisfied, so 3 and 1 we need to deal. So again we will just increase to we'll just do LP plus plus. So it will, this one won't get satisfied, it will come here and it will do LP plus plus, so it will point to 2. So what is happening, we are just checking LP is pointing to 1, so initially LP was pointing to 1 and RP was also pointing to 3, but we need to check for the left pointer element, whichever, if it is 2 or not, if it is 2 or not. So we do LP plus plus over here. Okay, it will come to 2. So now 2, this condition will get satisfied. Array left pointer is equal to 2. Yes, so it will get exchanged. So one more thing we need to note here is this will keep on going. Okay, so until RP is equal to 2, it will keep on going. So at one point it will, left pointer will become greater and right pointer will become lesser. So we just need to add this one also over here, RP, and add. So that's it. So after adding this one, it will, let's check. Okay, to change this. Okay, we need to return array. Okay, we should just replace this by to do okay friends, that's all. Thank you for watching. This is the elegant solution. And see, for this one also it will have O of n time and O of n space. So you might ask, this extra while loop is there, it will become n square. No, it is just doing one simple operation, and that operation, like, you can consider it negligible, because like it keeps on going, it just keeps on checking. This one you can neglect. This one will have negligible time complexity, because it will just keep on checking if it is until it comes on non to move number. So it will keep on iterating till it comes here. And yeah, so this one, since that's the only thing it does, we can ignore this one. So time complexity, we can ignore this while loop. So time complexity is O of n, and O of n time, and O of n space. Okay, so since we are returning one constant length arrays, so this is an O of we can take it as O of 1 space. Okay, so that's it guys, thank you for watching.